Yeah, so we have covered so far the basics of the architecture. We will go into the more details of the architecture during the backup recovery, because that is where all those things are required in much more detail. So a second phase of architecture, I usually would go in phases. Second phase of architecture again, especially the detailed discussion about the instance crash, instance recovery, the checkpointing process, all that we'll do in much more detail during the backup recovery discussion. So that is remaining. But in administration 1, what are the topics that are remaining? I think this is data pump, that is remaining, which is the backup tool. Then main thing, which is listener configuration, client configuration, network configuration, all that is just configuration. In fact, this is mostly the discussion. There are only 2 files that need to be changed, nothing more than that. So this is the major discussion. Then we have a smaller topic of shared server, that is remaining. Then we have a flashback. I think you have seen basic things in the SQL, but we will talk a little bit more about flashback also here. Or I may take flashback even after the recovery, because there is something called as flashback database, which is related to the recovery process. So all those things I may take after recovery, but this is something which is remaining. And yes, we haven't gone into the details of undo management. Undo management requires little more discussion. So those are kind of 5 topics which are kind of important. So I'm thinking that I would start with the listener today, the basics of the listener, and the theory part we will do, and then actually we will show the practical. After this, I think there would be more practical. So you asked, when the actual practicals will be done. So that is where we will be doing it. Okay, so we'll start with listener today. Now, this is our typical database instance. My SGA is here. My processes are here. These are 5 mandatory processes. And then my database is here. Database has data files, then control files, and then the redo files. So these are the 3 main areas of the database. Now, how do you log into a database? So far, the way we have been doing here is just SQL plus, and we give the login ID / the password. Normal user. If you want to log in as a sysdba, yes, we have seen that earlier. But a normal user will log in as SQL plus his user ID / his password. So how are we doing it now? We are doing it in such a way that this is a machine, that is our server machine. On this server machine, we have a database. And then we log on to the server machine using the SSH command. We have done that so far. And once we log on to the server machine using SSH, then we fire the command SQL plus. Obviously, before we fire the SQL plus command, we set Oracle SID is equal to the name of the instance that we would like to connect to. Because there may be 2-3 different instances that are running on the same machine, and we would like to connect to only one. So obviously, Oracle SID has to be set to the name of that instance by typing the export command. Is equal to, let us say, ABC. So we are going to connect to an Oracle instance called as ABC. SQL plus login ID password. This is the login ID password in that database we are trying to connect to. But what we have seen here, we have already logged on to the machine here on which the database is running. We are already logged on to the machine on which the database is running. Then does that mean that if you want to log into a database, you need to have the operating system login ID password? So 2 passwords. Do you really require 2 passwords? One to log on to the operating system on which the database is running, and one to log inside the database. The answer is not always. Okay, usually DBAs will log in like that, but normal users don't need to have the login ID and the password of the operating system. So how do they log in? They log in using a different way. all the applications, all the users, non-sys, non-DBA users. So let us say this is one user, one machine, different IP address in our range 172.24 IP address. This is 172.24.0.240. And now the person is logged on to this machine. That means he has the operating system login ID password of this machine, but he would directly like to log into this database. And when I say directly like to log into this database, that means he should start a dedicated server process here. Logging into a database, what is started? A dedicated server process is started. So how can a user log in from here to here? He types a command like SQL plus. On this machine he types the command. He is not logged on to this machine. On this machine he types the command SQL plus, the username is, let us say, XYZ, then the password is PQR, let us say, and the @ sign, and then he will type some word here. That word could be, let us say in this case, focus. A word, this is called as the connection string. A connection string is a word, it's a string which will somehow identify, yes, I would like to log on to a database whose name is maybe focus1. The connection string is focus, but the name of the instance that we are logging in could be focus1. Somehow there has to be a link between the connection string and the name of the instance that we are trying to log into. And that is done with this network setup and all that stuff. But the main point here is, how does the client log in from one machine to another machine? Using this help of the connection string.
After @ we can type directly the database name also?
No, we cannot. We cannot directly type the database name. We type the connection string there. And this connection string has nothing. How does it know this is the IP address of 172.24, let us say 0.10, and this is a totally different IP address? You have around 100 machines on your network. How does a SQL plus program running on this machine knows that it has to connect to a focus1 database on the machine 240? How does it know that? And that is with the help of the connection string. So how do we do it? That is what I'm going to talk about. But this is how it is done. So step number 1 is on the client side. So this is my client and this is my server. The client tries to connect to the server. So on the client side, step number 1 is install a software. Install Oracle client software. Oracle client software. You can go to the Oracle's website and download the Oracle client software. It is a big lengthy software, I think around 240 to 50 MB. It's a big software, and you have to download that software and install that software on the client machine. Oracle has come up with also a lighter version of that client called as an instant client. It has some limited functionality, but that can also allow you to connect to this. I would suggest right now, don't go with the lighter version, even though it takes longer time to download. Go and install the Oracle client software. Now Oracle client software, just like Oracle server software, has the versions. Okay, Oracle client 11 can connect to the database 10. So likewise, but if your database is 10G, I would suggest that you download the Oracle 10G client. Compatibility is easier to match. So that is step number 1. And then wherever the Oracle client software is installed, so let us say this is a Windows machine and this is a Unix machine. So we are trying to connect to a database instance running on the Unix machine from a Windows client. So we have installed the software number 1, and where are we going to, where have we installed it? Let us say it is in the C:\Oracle directory. That is where the entire software is installed. So this is now called as the Oracle Home on this machine. Oracle Home on this machine could be U01, APP, Oracle, all that stuff, but on the client side, this is the Oracle Home where you have installed the Oracle client software. Second thing, in that Oracle Home directory, there is a directory called as network, and in that network admin. and I'm writing a backslash because this is a Windows. If this was a Unix machine, also you can install the Oracle client software for Unix, and then I would say instead of C:Oracle, it would be something else, U01 something else. So Oracle home and network admin, that is the directory. This is the directory which has some special files on the client side, and that special file is tnsnames.ora. tnsnames.ora. That is the file on the client side which contains some information. That information is around 5 or 6 lines, and that information is going to be helpful for my SQL Plus program to connect to the database. That is what you have been, everybody on the client side, you guys do that. So tnsnames.ora, I guess everybody knows this thing. So we have to properly put the information over there. So I will tell you what information you have to put over there. Once that information is put, our client side configuration is done. Our client side configuration is done, and then once the client side configuration is done, the client can connect to the database. But obviously the server side configuration has to be done before that. So first we will talk about the client side configuration, and then we'll go to the server. So this is what is required on the client side. Now I need to look at my notes to see my TNS names. Okay. So now I'm going to talk about what information goes inside the tnsnames.ora file, and I will draw it means I will actually write down here. So tnsnames.ora,
if we put tnsnames.ora in bin file of Oracle, then we can connect any sort of Oracle database from our that window machine.
In which file of Oracle? No, I did not get. TNS names in which directory you said?
In bin, Oracle bin.
In Oracle's bin directory.
Yeah, right.
No, I don't think so. It has to be in the. I will tell you what needs to be done there. Where is my actual TNS names file? Okay. The location of that tnsnames.ora file must be inside network admin directory. Must be.
Yeah, it's in that network admin only the bin. Bin contains a particular folder of admin. Network admin. We have that sort of.
See, I will tell you, in your situation, it could be another variable. There is a variable called as tns admin. That must be set to point to that directory. We will come back to that after this discussion. But there is probably a different setup on that side, and that's why it is able to pick up the information from that file.
50 to 60 database in a one particular file, so that we can get connected.
Yeah. So what it is there, I will tell you what they have done. Okay, I know what they have done. It's on Windows machine, right? And somebody else is managing that file.
Right.
Okay, I will tell you what they have done. But yes, what it is on the client side, you have that software installed, and then inside that network admin directory of that software, where the software is installed, there must be that file tnsnames.ora. That is the default location. So just like the default location of SP file and P file is the DBS directory under Oracle Home, the default location of the tnsnames admin is going to be inside the network admin directory of Oracle Home. That is the default. So any client, when I type SQL plus login ID / password and @ the connection string, this SQL plus command this is the client program now, it is going to go inside the network admin directory, and it is going to search for a file called as the tnsnames.ora file. If it cannot find the tnsnames.ora file in that directory, it will complain, it will say that I cannot connect to the database, which is now FOCUS, which is now which can be connected by the connection string called as focus. So it will not able to find out that file. You cannot go further. But there is a trick to that. There is a variable called as tnsAdmin. tnsAdmin is a variable, just like our Oracle Home is a variable. This tnsAdmin variable, if you point it to, let us say, J colon, and in your case you mentioned bin directory or some other directory. If you point this variable to this, and if the tnsnames.ora file is sitting inside this directory, then all these commands will go and look at that file. So probably what has happened, there is one common drive on your in your organization, whatever that, it's not necessarily bin, it could be ABC, but your tnsnames variable has been tnsAdmin variable has been pointing to that directory, and therefore every program like SQL Plus or another program like Toad or SQL Developer, all these programs will go and take a look at the tnsnames.ora file in that directory. And then if the tnsnames.ora file gives the correct information, then only you will be able to connect to the database. So let us now see what information is there in the tnsnames file. So in the tnsnames.ora file, there are three important things over there, or four actually. Number one is the connection string. Connection string is, what is exactly the connection string? What is this connection string? It is nothing but a name given to an information. The name given to some information. And what is that information? The information is about the protocol. And in our case, the protocol is TCP/IP. So it will say that the client is going to connect to the database with the help of a protocol TCP/IP. So that is the name of the protocol is given under the connection string. So in our case, the name of my connection string was what? Focus. So what is the meaning of focus? The meaning of focus means, the first thing is protocol. Second thing is the IP address of the machine on which the database is running. So IP address, some people will use the IP address, some people will use the name. Okay, who should use name and who should use IP addresses? If your name of the machine, this is the machine name, or you can type it as a host name. This is the name of the machine on which the database is running. So in our case, 172.24.0.240, that is the machine on which our Focus 1 database is running. Okay, important thing to understand, the name of the database that is running is Focus 1, the name of my connection string is Focus. Only to emphasize the point that connection string can be given any name. Okay, in fact I will give a totally different name. I will give a name as Shaker. So my connection string is Shaker, which means the protocol for communication, it is telling you that you should use TCP/IP. You should connect to a IP address of 172.24.0.240. Then it will tell you the third thing now in this case is the port number. It's like this. Port number is basically a window inside the machine. It's a window to the machine. So like if you consider this building as a machine, you can come inside the building through any kind of window or any kind of door, and each door is either open or closed, and each door is given a number. So for example, if you are going to connect to a web server running on www.bbc.com, that www.bbc.com is a machine on which a web server program is running, but that program is, in a technical term, is saying is listening on a port number 80. 80 is the port number for web server. HTTP, yeah. So this is a well-known port number. Another well-known port number. If you want to fetch your email from a email program which is running on some other server, then you have to connect to SMTP port, which is port number 25. You have to connect to port number 21 to for FTP. So these are well-known port numbers, and similarly Oracle also has a port number which is a well-known port number 1521. Port number 1521. So that means the port number is written inside the tnsnames file. The IP address or the host number is written inside the tnsnames file. The protocol which should be used for communication between the client and server is also written inside the tnsnames file. All this information is written inside the tnsnames file, and that information is called as Shaker, and that is what my connection string is. And the fourth thing is actually the what we call as a service name, or many people in the old days we used to call it SID, system identifier, and that is our Oracle instance name. This is the instance name for Oracle that we would like to connect to. So what is happening here? I am saying that on that machine, okay, I am the client side, but on that machine which is having this IP address, I am going to connect to a focus 1, and this is going to be focus 1 now. Focus 1 instance. I am going to log in through a window 1521, the port is 1521, and to communicate with the program which is sitting on the other side of that window, I am going to use the language of TCP/IP. This information is now what is my connection string is. So this is written inside the tnsnames.ora, and the format of the TNS names is kind of very cryptic. I will, in fact, I wish I had a projector here. But these, you remember, these are the 4 things that are written inside the tnsnames.ora file. And then the name to that connection string is shaker. So what happens now? On the client side, I'm just going to type this simple command, SQL plus. I'm going to give the login ID and the password of this user ID. Let us say ABC. The password is also ABC. And the connection string is shaker. So what is the process behind the scene? Number 1, it will search for tnsnames.ora file. So this command, when you fire on the client side, it will search for the tnsnames.ora file. Default location is network admin inside the Oracle home. If it is not there, it will search for the first it will search for the tns_admin. If that directory contains a file called as tnsnames, it will be searched. And then inside that file, you will start searching for a connection string shaker. Once you find out the connection string shaker, and then all the information for that connection string, which is the IP address, the port number, the protocol, and the SID, the service number. Let me repeat: the IP address, the port number, the protocol, and the service that you would like to connect to. Then that process is called as a name resolution process. Name resolution. So what is the name resolution? People will ask you, what is the name resolution process in the client connectivity to the database? Name resolution is a process by which the connection string name is resolved to these 4 things: IP, port number, TCP/IP, which is the protocol, and the SID. That is what the name resolution is. And you will get many times an error message: cannot resolve name. Cannot resolve name. It means for some reason either you are not able to find the tnsnames file, or if you do find the tnsnames file, then there is no entry called a shaker inside that tnsnames file. Or if the entry shaker is there in that tnsnames file, then it does not contain the information in the proper format. The format of the tnsnames file is extremely important. Extremely. Even if you miss one parenthesis and equal to sign, everything will be and it will not give you any user-friendly messages. It will just keep on complaining, unable to resolve the name, unable to resolve name. So it is very important to create the tnsnames file. Now even today also, and in older days, we used to open up the VI and type everything in the tnsnames file. But these days, Oracle says that it is so sensitive about the format in the tnsnames file. Even if you miss a small space here and there, it will create problems. So we have created a tool called as NetCA, Net Configuration Assistant, Network Configuration Assistant. So they say that please start this tool. On the Unix, you can start this NetCA, but by just typing the command NetCA. Or on Windows, you have the actual startup and Oracle client and all that stuff. This NetCA will ask you 3 or 4 questions. 5 questions. That what is going to be your connection string name? You say shaker. It will ask you then what is going to be the IP address that you would like to connect to, the IP address of the server, what will be the port number, what will be the protocol, and what is the last thing? The IP address, the port number, the protocol, and the SID. So it will ask those 4 things, and it will say what should we call this as a connection string. So those 5 questions will be asked to you when this graphical tool NetCA will be started. And then you answer those questions and click on yes, finished, and that will go and put that information in your tnsnames file. So I would always recommend that you use the NetCA because it will save you from a lot of formatting errors. Always use NetCA. And then Using the NetCA, you create the TNS names file and your job is done. In one TNS names file, now the next point, in the one TNS names file, you can have many connection strings. Many connection strings. As you said, there are 20 different databases in your entire organization. Those are on 20 different servers, or maybe one machine contains two databases. All that information can be written in one TNS names file. In the organization, usually when a new employee joins in, he is given a new TNS names files by the DBA through email, and then he will put that into his network admin directory and he will start working. Because a new employee wouldn't know what is the IP address, what is the port number and all that stuff. So this is what the client-side client-side configuration is. Okay, let me repeat what are the 2 or 3 most important steps in the client-side configuration. Number 1, you need to install the software, which is Oracle Net software. After installing the software, you need to put a proper tnsnames.ora file, or you need to properly create the tnsnames.ora file in the network admin directory of the software, on the directory where the software was installed. To create the directory, you can use the NetCA command. Very simple graphical tool. That's why I don't have the computer in front of me, so I cannot show you here. But NetCA is a very simple tool which will create the TNS names file, and all you need to do is now type the SQL plus login ID / password and the @ sign. That is the connection string. If you are using any other software, for example, SQL Developer, a graphical tool, or a Toad, then they will ask you only 3 questions. What is the connection string? What is the login ID? What is the password? And it will also go after the same TNS names file. Everything is the same. So this is all about client-side configuration, and you will always get these name resolution errors if you are troubleshooting it. So what it means that it is either unable to find the tnsnames.ora file, or if it finds something is wrong there, or shaker entry is not there, all that stuff. So that's all about client-side connectivity. Kuch aur questions? And we'll see the server-side connectivity later.